Alright, we find ourselves on my desk again with some things to turn on here. And we have a request from the senior engineer. Many years ago, I bought a J-car clock. And it had a very interesting feature. I'll get some B-roll of that in a minute. Anyway, my senior engineer wanted that. In fact, originally it was intended as a gift for an ex-girlfriend who broke up with me midway through the design. And then it was coming up on my senior engineer's birthday, and I thought maybe I'll give it to him. Once I'd finished it, I didn't want to give it away again, and he's wanted one ever since. So he found the modernized version of this, which has got a whole bunch of extra features, including some of the features I've built into mine since, including either GPS or NTP, like Wi-Fi NTP time sync. Now this doesn't have nearly as many components as the previous one did, but crucially this one uses RGB LEDs, which means for every one of these there are 4 connections to solder, and there's some surface mount stuff to do, so this requires a slightly different discipline to one that I've had before. Now this is the original kit. This is no longer in production, and it uses an EEPROM, a big fat EEPROM up there. I have built in an ESP32 Wi-Fi relay into this to turn it off and on at midnight, but it has many useful features as well. Now, in the J-car magazine that is also gracefully included, this was Silicon Chip May 2025, features this whole kit. I did make some suggestions because he asked me about whether I should go Wi-Fi or GPS with it, and he got the nice little midgety little compact GPS module. Now where he plans to put this, it's probably going to have a bit of poor reception for GPS, but you know, if he plugs it in, takes it outside until it corrects the time and brings it back in again, then that's probably okay. Now I am a little bit under the weather at the moment, which is why I'm doing lots of desk jobs, and I had an accident with a kitchen knife a little while ago. So I have a few different choices for soldering iron tips, and I think I'm going to choose a medium-sized tip. This looks like it's going to be better for this job. Now, other preparations I'm going to take. Normally I use 1mm 6040 tin lead flux core solder. I'm going to go to 0.7mm, just a little bit thinner. Means I avoid over soldering things. Now, one other little prep I'm going to do here. If I was heat gunning this on a table, the table, even though in this case it's a wooden one, can actually wick away heat surprisingly fast. That, or at the very worst, it can burn the desk. So I'm putting some blue tack under here, and we're going to just space it off the desk a bit. That also stops it from sliding around. Okay, we're going to fire up our soldering station. Take a small amount here. This is fairly viscous because it's right at the end of the tube. Hasn't been out in a while. So surface tension definitely plays a part here. And so it will look very messy right now until flux is involved. But it's what you do when you're getting started. You do the easy stuff first and make sure it's going to work. Alright, it's going to go gently over the top until the solder paste starts to heat up and melt, and should form a bond. The problem with these tactile switches is you can melt the plastic on them. There we go. There's one solder ball going on. Let's get the other one up to temp. There we go. And hopefully this guy should sink down onto the board. May need to reheat just a little bit here and help position slightly. Alright, I'll let that cool off. Now, the more difficult bit we're going to have is going to be this bit here. So what I'm probably going to do here actually is flux this up and put a bit of tin lead on here and hopefully soften it with the heat gun. If you're going to do this, have a bit of isopropyl alcohol handy for cleaning the flux off things, because the stickiness of the flux can sometimes be greater than the weight of the components. In fact, it nearly always is. You heat both sides. Let's see if we can zoom in here. I'm going to try and preheat both sides because I want the chip to settle evenly. Just a tiny bit. Solder is soft. I think we'll be good. I'll let it cool off now. Right, I'll let it cool off. She's on quite firmly. We'll find out if the clock works afterwards, if all those connections are on. We would normally clean the flux up at this point, but we've got a bit more to do around here. And to be frank, these little switches over here are bugging me. So let's tackle this one. Reflow that one and reflow this one. Come on, push you back. That's much better. Alright, so for the next part, there's two 220 ohm resistors. I've got to go in here. This is the bag of components. Okay, so the black things are usually resistors, and they're usually numbered in the same way that IEC color codes are, in the way the digits work. So there is a 2200, so that would be first digit will be 2, second digit will be 2, third digit will be 0, and the multiplier would be 0. So that means that there is only 2 of these, and they will be 220 ohms. The rest will be used for other stuff. Now, fun fact, in a previous life I used to do hearing aid repairs, which had components way smaller than this. And I should really be filming this under a microscope. Here's a blob of blue tack. We're going to stick this down. Can you see that? Let's move up a bit. We're going to take a scalpel here, and I'm going to do this with my bare eyes and slit down both sides of this. And hopefully, if we stick it down a bit more firmly, across the top. And then that should allow me to flip these out one at a time. Delicate job though. There's one. Get in between the gap and underneath it. There we go, and it flew off across the table. Fortunately, I expected that, and I've dropped my tweezers on the floor. Yay for the inheriting of my senior engineer's skills of picking things up with my toes. Here are our 2 resistors right there. Take our blue tack out of the way. The one thing I did notice with this stuff is the flux content of the solder paste is a little bit low. So we're going to add a little bit of extra flux. Okay, now we've got quite a few to ball up, so I'm just going to lay a bead of this stuff down here and hope it works. Now, at this point, I should mention I play Minecraft on a server called anarcadia.org with the server owner, Zim. He always picks on me for having lights under my desk. Well, one of the reasons why they're so handy is I dropped one of these infinitesimally small things, and the lights under the desk helped me find it. But guaranteed it didn't drop the white side up. It dropped black side up on black carpet. Alright, for this bit I might time-lapse and montage it. My voice is not liking me. And I'm just going to start putting some components on, and we'll work from there. Okay, again, not the greatest job, but it's a job nonetheless, and we will clean them up a little bit. They all appear to be attached. Now I've got the capacitors. There's, I think, one goes there, a couple on the back. but we're almost done with the surface mat components. Right, now we've got the fun bit. We have a bunch of capacitors that are going to go in here, but the 100 nanofarad needs to go there. So let's go through our remaining components, which I think are these three, and see if we can determine which ones they are. Often I find that surface mount capacitors often don't appear to be marked. Alright, so we can do this by process of elimination. The only two similar or same value SMDs are 1 microfarad, and they go on the back. And the only other one that's left is this one, so this one needs to go on the front. Alright, we're going to get lazy with this one. Stuck it down with some solder paste and a blob of flux on the top. This is how they should work. They should just suck straight onto the pad like that. See? That's where that surface tension popped and it pulled it onto the pad perfectly. Yep, they're pulling onto the pads now. Beautiful. Low airspeed. That was like right down to almost minimum airspeed there. Alright, because I don't want to open that bag of chaos, I have some that I prepared earlier. I have a blue and a green 5mm LED right here. Stick it down, flip over and solder with 6040 tin lead, flux core. Yeah, this is the good stuff. I went back to the 1mm. This stuff just works so much better. Beautiful. Now that's a 100k ohm resistor. Now I thought I had a spare and I went, you know what, I can probably throw it away. I'm glad I didn't. Alright, zoomy zoom. This little component here is what we're going to do. We're going to stick you on. So if I just squeeze a little bit here, a drop will form and it will drop on top, which hopefully doesn't disturb it too much. It did. Right, bring you back. There we go. There goes one. And there goes the other. Alright, she's on. And a bit of circuit board cleaner and a tissue to wipe off the excess flux. Okay, we can peel off our blue tack. Oh, it's a little bit warm on this side of the board. There we go. And that's going to be a pin header we'll put in later. I'm probably going to look in at doing some of these soon. Okay, so day 2 and our LEDs are all in place. This pin density is quite narrow, and it does make with solder bridging a little bit of an issue, so I had to go over with some flux and some solder wick for a few of them, but also I was using 1mm solder. Had I gone back to the 0.7mm stuff, probably would have worked a little bit better, but you know, old habits die hard. I still have to clean this up. I've given it a bit of a spray with some circuit board cleaner, which is something you can get at JCar. But I'll give it a proper scrub later. There's still a couple more things to go on. As you can tell from my voice, it's too early in the morning, so I'm going to do them in a little bit. Okay, so we're pretty much done here. We've got all our LEDs, all our surface mount components, all our pin headers, our lead for the GPS done, and we've even got little wire loops here. I think are hanging loops. Depending on how industrious I get, I may laser cut a proper mounting for this, but we'll see how we go. We're getting dangerously close to being able to test this. Alright, it has come to first test time. Now this is supposed to work between 5 and 12 volts. We're going to give it 9 volts, and we've double checked that center positive is correct. So let's see what happens. Looks to be working correct at the moment. See how we go. It's running around nicely. Looks like all the LEDs are doing their right thing. So, it looks like I've got all the LEDs working first shot. That's a good effort. Although I did take time to check them all. So, very happy with that. I also infer from the little blue light on the back here that GPS module is powered up correctly as well. We might have done a reasonable job. These little regulators are not cooking themselves. They're not super hot. I think we're all right. Okay, so I stuck this near a window for a bit and it actually got the correct time. Now, when it's doing this self-test and it's running around with green LEDs, that means the GPS is working, but it's not getting any time data. If it was red, that would mean it's not getting valid data from the GPS. You've got something wrong. It looks like I've got everything correct here, straight out of the box. Alright, so while we had it on my desk, it previously lost sync just for a little bit, and then it's gone back to having correct time again. I've got to learn to read this, although it's 10:42 at the moment. So I'm going to guess that's the hour hand, and this is the minute hand here. Yep, and it's moving its way around. So that's the second hand, this is your minute hand. Looks pretty cool. There's a bunch of configurable options in this. I'm not going to go through them in this video, but it looks like we've done things right.
6 hours later.
Alright, skip forward a whole day. I built a case for it. And then it stopped picking up GPS signal. And then I set it to baud rate 6 and it reckons it's got it again. Left it in the window for a bit and now it's doing this. I don't know what this means. I think this means maybe it's not getting GPS data. But we have a nice case for it. I've put sticky labels on to indicate everything. So this indicates it's on baud rate 6. The green chaser indicates it's getting data. If we were to change it to one that doesn't, which we can't for the moment, but it changes these for the 1 through 6 for baud rates. Green means it's getting a signal from the GPS module, which is powered up. Doesn't have a valid time yet. It'll sit like this till it gets one. I'll put it back in the window, see what works, but I think I'm going to screw everything back together, and I might present this to my my senior engineer, and hopefully he likes his new kit. We'll work on the colouring and everything else later. This has just been fun to build. Call it quits and we'll see you in the next one.